Okay, this lesson is on pulley and incline plane problems. So in these problems, there's the combination of a pulley system and an incline plane. There's two problems we'll look at. These two problems integrate both system studies so far. Examine the concepts and the conclusions made about solving these systems before attempting these. Note that both blocks are accelerating, therefore a net force must be acting on each, which is equal. Newton's second law can be used separately for each block to relate net force and acceleration, and both blocks have the same acceleration because they move together as one object. So in the first example, we have a 6 kilogram block attached to a free hanging 6 kilogram block attached to a 5 kilogram block on an inclined plane. So we're going to examine the forces that are existing on this. So this is all taking the topics that we covered on pulley systems and inclined planes and combining them together. So the concepts are the same. So there's a force acting down on the 6 kilogram block, which we'll call Fg1. And there's a tension force acting upward. There's also a force of gravity acting down on the 5 kilogram block. And that force of gravity is broken down into an x component, which we'll call Fgx, and a y component, which is perpendicular to the inclined plane, which we'll call Fgy. And there is a normal force acting on the block, Fn. Now note that this is excluding friction, so there is no frictional force acting on the 5 kilogram block. So the first thing that we need to do is figure out the direction of motion. Is this block going to move down the inclined plane, or is the 6 kilogram block going to move down in this direction? So we have to figure that out first. So we're going to calculate the net force on the system, the acceleration of both masses, and the tension in the cord connecting the blocks. So step one, determine the direction of motion. So to do that, we have to compare Fg1, the force of gravity on mass 1, with the force of gravity on mass 2 in the x direction. So Fg1 equals m1 times g, which equals 6.0 times 9.8, which equals 58.8 newtons. And Fgx, which equals m2 times g times sine 65, which equals 5 times 9.8 times sine 65, which equals 44.4 newtons. So since Fg1 is greater than Fgx, that means the 6 kilogram mass is going to move downward. So the downward direction of the 6 kilogram mass is going to be the direction, the positive direction. So Fg1 is greater than Fgx. Okay. Step two, we're going to calculate the net force acting on the 6 kilogram mass, on the system as a whole. So the sum of the forces, and I should go back and just show this really quickly. So the forces that create the net force that we're looking at is we have Fg1 here, and we have a tension force here. And I forgot to mention the tension force is acting here as well. And then we have FGX. These are the four forces that act to accelerate the mass in the direction of motion. So the sum of the forces is equal to Fg1 plus Fgx plus tension minus tension. And the tension forces just cancel out. And so we get 58.8 newtons minus 44.4 newtons, which equals 14.4 newtons. So that's your net force. Next, we're going to calculate the acceleration. So acceleration is equal to net force divided by mass, which equals 14.4 newtons divided by 5 plus 6 kilograms, which equals 1.3 meters per second squared. And finally, we're going to calculate the tension force. So we're going to isolate M1, the 6 kilogram mass, and Fg1 plus the tension force on the 6 kilogram mass is equal to the mass itself times acceleration. This is just Newton's second law. F net equals ma. So we're just isolating one of the masses. You can isolate the 5 kilogram mass and you would get the same tension force, but it would be a little bit easier to just use the 6 kilogram mass. So we get 58.8 newtons plus the tension force equals 6 times 1.3. And if we isolate T, we get tension equals negative 51 newtons. Okay. Next, we're going to look at a situation that includes friction. For these blocks on the incline, assume that they start at rest and that the coefficient of friction between the block and the ramp is 0.2. Don't forget to draw a free body diagram. So in this case, this is a little bit more complex because there is some friction acting on the blocks. So just drawing a simplified free body diagram, we have Fg1, our tension force Fgx, and then friction will act opposite the direction of motion. So we already determined the direction of motion by comparing Fg1 with Fgx. So that's what you need to do. You need to compare those two values to see which is greater. If Fgx is greater, then friction would act in this direction up the inclined plane. But since the 6 kilogram mass has a greater force of gravity, then we know that motion is actually traveling downwards in this direction. And so the force of friction is going to act in the same direction as Fgx. So that's that can be a confusing point. So friction is going to act opposite the direction of motion. So the first step is to determine the direction of motion and then determine which direction friction is going to act. So step one, determine the direction of friction. So again, Fg1 is greater than Fgx. So we compare those two values. So F friction will act in the same direction as Fgx. Okay. So friction acts down the ramp. Okay. So we're going to find F net. So F net in this case is going to equal Fg1 plus Fgx plus F friction. And Fg1 is equal to 58.8 newtons. Fgx, and we calculated that in the last example, is equal to 44.4 newtons. And F friction, we have to calculate that, is equal to Fgy times 0.2, which equals 5 times 9.8 times cos 65 times 0.2, which equals 4.14 newtons. So we plug in all our values into F net, which equals 58.8 minus 44.4 minus 4.14. So notice that the Fgx value is the same sign as frictional value because they're acting down the ramp. And that's equal to 10.26 newtons. Next, we're going to calculate the acceleration. So acceleration is equal to F net divided by mass, which equals 10.26 divided by 11, which equals 0.93 meters per second squared. So slightly less than the acceleration without friction, which was 1.3. And finally, we're going to isolate the 6 kilogram mass again, just like we did last time. And we're going to find the tension force. So Fg1 plus tension equals M1 times A. So 58.8 newtons plus tension force equals 6 times 0.93. And isolating tension, we get negative 53.2. Okay, and that concludes the presentation.